We are now recording. Let me get the slideshow set up for. Okay. Yes. Yes, I'll be glad to answer. Okay, let me go over that in a minute too. Let me get this set up because I have to get out of presenter view because that doesn't send over Screencast-O-Matic well. Okay, now I will not work a quiz question in class. I'll answer and clarify a quiz question, but what I will work is anything from the book that's similar to a quiz question. Okay, so you have one? Okay. Or is it about the content of the question, or you just can't read it well, or what the deal?
I'm unfamiliar with the steps to do it.
Okay, well then find one like it in the book. Yeah. Is what? I couldn't hear.
The number.
What number?
I'm saying, on the problem, it's
Oh.
the number. But I went
Oh.
the problem is similar with all the ones that's similar to it, you can factor it. But
Okay.
I can't find the number for this.
Okay. Okay, what are we talking about? Okay, wait, let me lay my hands on it again. I set them down. Okay, which one? Number 6. Okay. And you're saying that's not factorable?
Oh, no. That's okay.
Okay. All right. Was there something else? Okay. And by the way, that was a difference of 2 perfect squares, right? Or at least that's what it looks like it might be. How can you tell if a number's a perfect square? Especially a big one like that. It's not one of the ones we're familiar with. Pull out your good old calculator, take the square root of it, and see if it's a perfect square. If it comes out a decimal number, it's not a perfect square. If it comes out a whole number, it is a perfect square. Okay. Any others? Okay, if you find anything you don't know, can't understand on the quiz, if it's clarifying it, I'll do that. But if it's, how to work it, find one like it in the book. All right. We did example 1, but then they did not show on the slide set any other examples until they get to 7. So this, we're going to do example 6. All right. This is one similar to 5, but a little bit different. Here's what we have. X minus 1 times x plus 9 is equal to 11. Now this looks really like good news here, right? They've already factored it for us, right? Is that good, bad, or indifferent? In this problem, totally useless. Why? If that was a 0 over there, we'd be singing in the streets because all we have to do is solve it. With this not being 0, there's no 11 product rule. There's only a 0 product rule. So this doesn't do you any good. What have you got to do first? Second? Okay, we will, but what you need to do to the left-hand side at some point, you got to FOIL it and get it back together again, and that would give you x squared. Second? Plus 9x minus x minus 9 equal 11. Okay, now you can do what? Okay, and how about combining like terms at the same time? X squared plus 8x minus 9. Subtract 11 from both sides, and that would make that minus 9a minus 20. Okay? Ooh, I hit the eraser and it didn't come through. Ah, there we go. Thing gets stubborn in the mornings, it seems like. Minus 20 is equal to what? 0. Now we want to factor. Okay? So how are we going to do that? If it's factorable, we don't know this for sure. What will we do? Okay? The only possible factorization for x squared is x times x. That's called doing the x. Okay? Look at the sign of the last term, and what is that? That tells you what? These are going to be different, so we'll put which way you want to go. Plus and minus, that sounds good to me. Now we want two numbers, because these are different signs. We want two numbers that multiply to be 20, but the difference is 8. 10 and 2, and which one's larger? Okay, which one goes with the plus sign? The 10. And 2 here. And you can foil that again. See, that works. X squared minus 2x minus plus 10x is plus 8x minus 20. Got it. So where do we go from here? Okay, and that would be? Okay, he's doing it right off the top of his head. X equal negative 10 or x equal positive 2. Does everybody see how he did that? Okay, if you didn't, take the time and do it. That means product of two entities equals 0. Either x plus 10 is equal to 0, or x minus 2 is equal to 0. Subtract 10 from both sides, add 2 to both sides. Okay, take all the steps you need. This is not a time issue. Okay, so there are two solutions. Okay, not a bad idea to go back and check them. Let's put the minus 10 in the original. Don't do it anywhere else, the original. Minus 10 minus 1 is minus 11 times minus 10 plus 9 is minus 10 plus 9, negative 1. Minus 11 times negative 1 is? Say again? Minus 11 times minus 1. Positive 11. Bingo. Oh, we can't say that in Alabama. Okay, that works. Okay? All right, how about the 2? What happens if we put a 2 in here? Two minus 1 is? 1. 2 plus 9 is? 9. 1 times 11 is? 11. It worked. Fantastic. Any questions on that? The solution set, if you write it the way the book does, which is probably in the back of the book this way, negative 10 and 2. All right, any questions on that? All right, now the first thing that's going to show up is that example 1. We've already done that, so that's not worrying about that. Now we're moving. Does anyone need this a little longer? Okay. Solving word problems, what we love to do, right? Almost as much as working fractions, right? Okay. Maybe we'll get word problems with fractions. Okay. A cryptographer needs to arrange 60 numbers in a rectangular array in which the number of columns is 2 more than twice the number of rows. Find the number of rows and the number of columns. Okay? So you got 60 numbers. I'm not going to do 60, but here's what we're talking about. Rectangular array. So this is not going to be the answer, but here's what we mean. That is a rectangular array. Now it's not the one we're looking for, but the numbers form a rectangle. Okay? We know the total number of numbers is 60. You could think about this as chairs in a room. You have 60 chairs in a big room, and you're wanting to arrange them in this manner, okay? So it doesn't have to be numbers, okay? In which the number of columns is 2 more than twice the number of rows find the number of rows and the number of columns. Now, I suggest it to look for the question. Now, it's not really a question here. It's a Colton Turner. All right. It's not really a question. Where is it telling you what you're looking for? What are you looking for? Number of rows and the number of columns. So let's name those for now. We're going to not keep them too long, but we'll name them for now. What you want to name the number of rows? R. Good choice. Let R equal the number of rows. And C equal number of columns. Okay. Now we go back up here and read this second phrase here, in which the number of columns, what's that? C is, how does that translate into? Second? Is equal to 2 more than twice the number of rows. What's the number of rows? R. Twice the number of rows would be 2R. 2 more than that would be, I'm sorry? Plus 2, is that what you said? I like it. Okay? I don't know if that's what you said, but I can't hear, okay? So I can get away with it. So here we have a sentence. There is it's a phrase in the sentence here. We've written it as a mathematical sentence. C, the number of columns, is equal to 2 more than twice the number of rows. 2R is the number of rows. 2 more than that is 2R plus 2. Right? So let's write that down a little bit neater down here. C is equal to 2R plus 2. Okay? So, this is the number of rows. There's a row, there's a row, there's a row, there's a row. Here, column, 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 column. Okay, now this isn't the one we're looking for. How would you get, okay, got what they have so far. One piece of information we haven't used yet. What's that? 60. What is 60? Total number of numbers, okay? So, how do you get this? If you have R rows and 2R plus 2 columns, how do you find out where do you get the 60 from that? Remember this? Say again?
Maybe start with R first.
Okay, wait, not yet, okay? You've got R rows and 2R plus 2 columns. Let's just take what I have, okay? I had 1, 2, 3, 4, 5, 6, 7 columns and 4 rows. How many numbers did I have? 28. Okay, how'd you get that? 7 times 4. Well, now we have R rows and 2R plus 2 columns. How are we going to get the 60? Okay. Don't you multiply number of rows by column? Okay. Number of rows was? Okay. 2R. I'm waiting. How many rows do we have? R. Times how many columns we have? 2R plus 2. And what's that equal to? 60. All right. Isn't this a lot like the problems we just did? Okay. There's our equation. You get it by number of rows times number of columns is equal to the total number of numbers. Okay. I prefer chairs or something else. Number of numbers that, but actually you do have things like this that you run into. So how do we solve this equation? There's the equation to be solved. Most of our time is spent setting it up. Solving it's not so bad. How do you do that? Second, distribute, and what do you get? 2r squared plus 2r equals 60. Okay? You didn't take advantage of the factor here? No, it doesn't do you any good because that's not a 0, it's a 60. So what do we do now? Help me, help me. Yeah, so how do we do that? Subtract 60 from both sides. Or you bring it over, which is 2r squared plus 2r minus 60 equals 0. Is there anything you see you might want to do first? Okay. No like terms. Say again?
See what number you go with each one of them.
Okay. What would? 2. Okay, what do you do with it? Say again? Ah, I like it. Now, you can either factor out the 2, or since it's an equation, you can divide everything by 2. Divide this by 2, you get a 1. This by 2, you get a 1. This by 2, you get a 30. And 0 divided by 2 is 0. Okay. So that now gives us r squared plus r minus 30 equals 0. How do we solve that equation? Say again? Okay. Unfoil it. Okay, that's my silly way of saying it. What does that unfoil to? First is r times r. Okay, and what is it? What does that tell you? Say again? They got to be different. One's going to be plus and one's going to be minus. Now we want two, because they're different signs, we want two numbers to multiply to be 30, but their difference, because they're different, is 1. 5 and 6, which goes where? 6 goes with the plus because plus wins, and 5 goes with the minus. Okay? Now what does that tell us? -6, or r is equal to 5. Okay, I want someone to come up and draw me on the board a matrix of number with -6 rows. What's that? It's impossible. You're absolutely right. I can't hear. It's impossible to do -6 rows. So we throw away one of these. And which one's that? The -6. So we have r rows. That answers the first part of our problem. R is equal to 5 rows of numbers. Okay? Now we have to figure out the number of columns. Plug it in right here. C is equal to 2 times 5 plus 2. That's equal to 12. 12 columns. Okay? And that's a good way to check. Multiply rows by columns, and what do you get? 60. Fantastic. It works out nicely. Make sense? Any questions about it? Pretty straightforward. Don't get bogged down too much. Translate English into math. It's exactly what we did here. Once we identify what we're looking for, rows and columns, then see which one we know the least about. We don't know anything about rows, but we do know the number of columns is two more than twice the number of rows, so we know something about that. So get columns in terms of rows, then multiply because this is a rectangle, length times width, that type of thing. You got it. All right, that's how we did it. Let's see how they did it. Okay? They let R be the number of rows. Clever of them. Then they didn't write down the translation, but we did. 2R plus 2. represents the number of columns. Because it's a rectangular array, the number of rows times the number of columns is equal to the total number, which is 60. But then you have to multiply that together and distribute. 2r squared plus 2r is equal to 60. They wrote it down again because they were at the bottom of their slide. And they factored out the 2. We divided out the 2, same difference. Okay. Then they factored what was left, r plus 6 times r minus 5. They got that right. Now, doing it this way, you can say, well, either 2 is equal to 0, r plus 6 is equal to 0, or r minus 5 is equal to 0. Was 2 ever equal to 0? No. Okay, it can't be, so throw that one away. Then r plus 6 equals 0, or r minus 5 is equal to 0. They're doing every step here. And then solving the first is r is equal to negative 6. Solving the second, r is equal to 5. But this stands for number of rows. You can't have negative 6 rows, okay? That solution, throw that one away too. There are 5 rows, and then 2r plus 2. 2 times 5 is 10 plus 2, 12 columns. 5 times 12, 60, that works. Any questions? Okay? Good deal. Now, they're skipping example 8. I know y'all love your word problems, so you don't want to skip a single one, do you? I didn't think so. Okay. You want to do as many as possible, right? A strip of uniform width cut from both sides and both ends of a 5 by 7 inch photograph reduces the size of the photo to an area of 15 square inches. Find the width of the strip. Now, this is not this problem. I'm going to try to draw the picture. The books are maybe a little bit better than mine, but not much. Okay? This is 5. Call that 7. Okay? 5 and 7. Okay? Now what it says, a strip of uniform width is cut from both the sides and both ends of this photograph. All right. So I'm going to try to do like they did. There's my cut on that end, and my cut on that end, and my cut up here, and my cut down here. Whoops, I didn't do that one too well. But these are all the same. Okay? Find the width of the strip. What are we looking for? The width of the strip. What you want to call that width of the strip? W. Why not? So let W equal the width of the strip. Okay? That means this is W, that's W, this is W, that's W, this is W, that's W, this is W, and that's W. The width there is W. Okay. Started out a 5 by 7 photograph. You want to cut this off so that you have an area of 15 square inches. So this what's left inside the dots is going to be 15 square inches. Okay? Just inside the dotted lines. Okay? Now, what's the question? The width of the strip. Okay? How are we going to do this? You know the area in here, right? What's the area? It's still rectangular. In. What's the area of a rectangle? L times W. What's your L here? It started off being a 7, and you lost 2W. You lost a W on each end. So the new length here is 7 minus 2W. What's your width here? It started off 5 and you lost 2W. So the width in here is 5 minus 2W. Can you see an equation coming out of this? What? 7 minus 2W times 5 minus 2W equals 15 square inches. You got it. So what do we got to do first? FOIL it. Okay, curse is foiled again. What do you get? 35 second minus 14W minus 10W plus 4W squared is equal to 15. Okay, let's rearrange, combine like terms, that kind of stuff. Let's put my, that's a 4 there. I can't read my own writing. 4W squared. That's, yeah, this is 2W times 2W is 4W squared. I wrote it too close together. I was running out of room. Let me clean that up a little bit. Okay, 4W squared. Okay, so 4W squared minus 24W plus 35 equal 15. Now what? A little louder. Subtract 15, thank you, okay, from both sides. I'm hard of hearing. 4W squared minus 24W plus 20 equals 0. Ha, that's what we want. What do you want to do next? A little louder. How? Second? Okay, right, the parentheses. She likes to work harder than I do. Factor out of what? 4. Okay, you want to factor it out, divide it out? I don't care. I'll divide it out. Okay, then 4 go into 4 once, 4 go into 24 6 times. 4 will go into 20 5 times. So our new problem is W squared minus 6W plus 5 equal 0. All right. What do we do now? I'm guessing we split it up. What's the first factor? Okay, well, let's do W times W. Okay. And then sign is negative and negative. And really? Which way? 5 and 1. Okay. 5 and 1. That'll work. 2 and 3 comes close, but doesn't quite make it. Okay. What does that tell you? Either W is equal to 5 inches or W is equal to 1 inch. Okay? Now I want you to get me a 5x7 picture and cut 5-inch border off each end and each top and bottom. Can you do it? 5 inches here would be here, 5 inches here would be there, 5 inches here would be there, 5 inches there. You wouldn't have anything left. In fact, you have less than anything left. So the 5-inch border isn't going to hack it, okay? Will a 1-inch border work? What will be your dimensions left? You cut 1 inch off of each end of a 7-inch and you get, say again, 5. And cut 1 inch off of each of a 5-inch by 3, and guess what that gives you? 15, yes, 15 square inches. That looks like that will work, okay? So we found the W, we checked it, it works, okay? 5-inch border will not, you don't have enough picture there to do it, okay? So you have a border of 1 inch. Okay. Now, any questions on that? Do you see the procedure? Drawing pictures are worth a lot Pictures are worth thousands of words in math, okay? So please draw your picture. Help yourself see it, okay? All right, then this is the answer to 7. We've already done that. So let's do, here's another type of word problem you have. Anyone ever heard of this guy? Pythagorean theorem. And by the way, Pythagoras would be a good paper topic. Who in the world was he? How did he develop the Pythagorean theorem? You know, another one would be, is he the only one to develop the Pythagorean theorem? Has it ever been proven? Like hundreds of different ways. In fact, a former president of the U.S. came up with unique proof of the Pythagorean theorem way back. Okay, so quite an extensive number of papers you could get out of that one little thing. Pythagorean theorem, an important theorem pertaining to right triangles. What do we mean by right triangles? Second. Okay, it has a 90-degree angle. Okay, can it have more than one? No, because what's the sum of the 3 angles on a right triangle? 180. So if you have one 90, the other 90 never would make a triangle. Okay, so yeah, only has one. So what about that right triangle? Well, the side opposite this, because this angle is obviously less than 90, that one's obviously less than 90, because the 2 of these have to add to 90 to get 180. So that means that these 2, the side opposite the small angle is the shortest side. The side opposite the next smallest angle is the next shortest side. And the side opposite the right angle, which is the biggest angle, has got to be the longest side. We give a special name to that. That long side of a right triangle. Hypotenuse, exactly. Okay? It's called the hypotenuse. Good old Greek word. Okay? He reads well. Okay. So, here's what Pythagorean theorem says. The sum of the squares of the 2 sides, the short sides, a squared plus b squared, has to equal the square of the hypotenuse of the long side. Amazingly, this works. Okay? And as I said, Pythagoras wasn't the first to come up with it, but he's the first to document it and prove it, at least that we know of. You know, the sad, it's not sad, but it's reality, is that much of what we consider knowledge that's been developed in Europe or places like that actually was old hat in China long before we knew it. We just don't have the documentation to show it, but they were using, they probably didn't call it Pythagorean theorem, but they were using similar, probably hundreds of years before Pythagoras lived. Okay, well here's your Pythagorean triangle. Okay, Pythagorean theorem. Okay, now, and by the way, they sometimes call the 2 short sides the legs of the triangle. Whoa! They don't do the example, so I guess we'll do that. So I think what I'll do is go back and clean this page. Oops, wrong thing. All right, here's example 9. One leg of a right triangle. So I'm going to try to draw me a right triangle. My right triangles aren't really all that pretty, but let's just pretend that's a right angle. Okay? One leg of a right triangle is 2 centimeters more than twice as long as the other leg. So which one is the long leg and which is the short leg? One's called the one leg and the other's called the other leg. Which one's the long, which is short? One or other? Huh? It helps to have the book open, but okay. I'll write it down. One, that's a pretty ugly one. One leg of a right triangle, I'm going to abbreviate that, is 2 centimeters longer than than is more than, oh, I'm sorry, it's more than twice as long as the other leg, period. The hypotenuse, okay, is 1 centimeter longer than, that's what I was looking at, the longer than, the longer of the two legs. Okay. Find the lengths of the three sides. Okay. Now, find the lengths of the three sides. You can either start out with 3 different letters, one for each side. You can do that. Or you can first figure out the one you know the least about and build on that. So I don't care which way you go. You tell me. How would you like to? Say again? Each side. How do you want to label these? Okay, which one you want to call A? Okay, that's A, this B, and that's C. Okay, the only thing that really matters is C had better be that hypotenuse, okay, because that's what the Pythagorean theorem says. A and B are interchangeable. Okay. Now, that's how you named them. Which they name them one leg, other leg, and hypotenuse. Okay? I want you to identify which one's A, which one's B, and which one's C. A is which? A is one leg. Okay, so we'll call this A. Okay, one leg of a right triangle is, how does that translate? Equal to 2 centimeters longer than twice as long as the other leg. Other leg you called B. What is 2 centimeters longer than twice as long as the other leg? 2B or not, plus 2. 2 longer than. Okay, hypotenuse is what? C is equal to, second, which is a longer leg? Now they give another name. Second, A. So what do we mean by 1 centimeter longer than A? What would that be? 1 plus A, or A plus 1. Doesn't matter which way you write that. Okay? Find the lengths of the three sides. Okay? Well, we've identified them. Okay? Let me write down our three equations here. A is equal to 2B plus 2. All right? Yeah. C is equal to A plus 1. Okay? Now, what I suggest is taking this and plugging it in for A. So, no, actually not. Let's not do that. Okay? Don't take that away. Ooh, I thought it was. Okay. And basically, this sounds stupid, but it is, B is equal to B. Okay? Is that all right? Okay. Now I do want to do what I said. Let's write down this and plug it in for A, because that's what A is equal to, right? C is equal to, instead of A, we're going to write 2B plus 2 plus 1, right? A plus 1. So this is equal to 2B plus 3. All right. Now we got b is equal to b, a is equal to 2b plus 2, and c is equal to 2b plus 3. Now we can plug those in Pythagorean theorem, right? How would that go? Well, you tell me what Pythagorean theorem says. A squared plus b squared equals c squared. Ooh. All right. So A is 2b plus 2 squared plus b is b squared equal to c is 2b plus 3 squared. Now we have one equation, one variable. We just got to deal with it. Okay, I'm kind of running out of room here, so let's clean up the best we can. What is that first polynomial squared, binomial squared? What does that give us? 4b squared plus 8b, excellent. Remember, twice the product, plus 4 plus b squared equal to 4b squared. Sorry about this. Let me erase some stuff here because it's getting messy. Okay, let's take this triangle out of here. We drew our picture, we've used it. We're going to throw it away now. Just use it and throw it away. Okay, what does this give you? A little louder. 12. Twice the product is 12b. All right, say 12 and write 2. Plus 9. All right. Now, what might we do now? Say again? Okay. By that you mean moving them from one side to the other? Okay, I like the idea. What might you do first? Now, okay, wait. I think I understand what you're saying. This has b squared, and you want to combine those here, right? That is a good idea. That's technically what you should do first. But I'm really lazy. And I see if I subtract the 4b squared here from the 4c squared there, I'll lose both of those. So I don't have to add those two together. Is that okay to do? Is that legal? Subtract the same thing from both sides? This is just being lazy. You don't have to do it this way, but sure is simpler. Subtract 4b squared from both sides. They disappear. Now you've got a b squared. And now let's deal with this. What do we do with the 12b? Subtract that from both sides. And the 9, subtract 9 from both sides. So that gives me the b squared minus 4b plus, no, minus. Who said plus? Okay. Whoa, that's not what I wanted. Oh, no. How do I undo that? There we go. These things pop up and then they disappear. Okay. So you have b squared minus 4b minus 5. We've already used that. We subtracted all these away, so this gives us 0. That's what we want. Okay? So let's get, oh, I go to erase and it doesn't do it. Okay. I just need more room. Okay. All right. What do we do now? Factor. What does that give us? B minus and plus. 5 and 1. That sure works. So what does that tell you? Oh, I erased what I wanted to keep. Yuck. Okay. B, 5 centimeters, or B is equal to -1 centimeter. Can someone draw me a right triangle with a side -1 centimeter in length? No. This one makes no sense physically, so we throw it away. Now we have to go back and get our other two, and I erased them. Sorry about that. One of these was A is equal to 2B plus 2. So what does that give us? 12 centimeters. And C was equal to, remember it was 2B plus 3. And that was going to be one more than that. Help me, help me. 13 centimeters. Now let's see if that indeed is a right triangle. B is equal to 5, A is equal to 12, C is equal to 13. What's 5 squared? 12 squared. 144. 144 plus 25. 169. Guess what that is? 13 squared. Check it. It is. So sure enough, that is. And by the way, let me just give you a few. These are called Pythagorean triangles or perfect triangles, these that have whole numbers. Most of your right triangles will have square roots in them. These do not. The simplest of these is the 3, 4, 5 triangle. 3 squared is 9, 4 squared is 16 plus 9 is 25. That's a 5. 3, 4, 5 triangle. Okay? Always a right angle between the 3 and the 4. Okay? Always. Now, when I grew up on a farm, my father was an ag engineer, but he didn't want to work for somebody. He wanted to farm. He always loved farming. So we built our own sheds. He took care of his own equipment. He did all this kind of stuff. And when we would go to build the shed or a building or anything else, we took just an inordinate amount of time making sure that structure was square. And how he did it was 3, 4, 5 triangle. He'd measure up 3, 4, and 5 and make sure he got that angle to 3 feet, 4 feet, 5 feet. You knew that you had a right angle there. Knew it if you measured it out that way. And then he did other things like make sure the diagonals were equal. You know, there were all sorts of things he did. Basically, Pythagorean theorem, you use it. Okay? Real. Now, 5, 12, 13 is another perfect Pythagorean triangle. And I think this is true. I'm not absolutely certain. The first one was 3, 4, 5. Okay, right? Then you start with the hypotenuse of this one, 5. 5 squared is 25. 12 and 13 is 25. Okay? So if you start with 13, that's going to be the next one. And 13 squared is 169. And find 2 numbers to add to that, that's going to be another one. Now, those are all your perfect Pythagorean triangles, but that's how you get some of them anyway. Okay, that's beside the point. We found the 3 sides. That's what they're asking for. We checked it. It works. All right, this is example 7. And they got in their book, 3, 4, 5, 12, and 13 centimeters. Okay, that's the last slide in 3.7. There's a conceptual quiz here, true, false. Don't expect many of these on the test, but think through this. Make sure you understand it. If once you've figured it out, then check your answers on the next page. Homework exercises here. Do any of the odds 1 through 53. Then do any of the problems 55 through 69. Okay? Do some with Pythagorean theorem, some just others. They love these about, and here's a couple of things. What do we mean by consecutive integers? Oh, say again?
What page?
This is page 170 and 171. Okay? They like these problems like consecutive integers. Okay? Such as number 55. Find two consecutive integers whose product is 72. How do you do that? What do we mean by consecutive integers? Okay, so you need to come up with an unknown. So pick the first one. Let it be what? No, variable. A. Okay, let it be A. What would be the next consecutive integer after A? Okay, except it would be A plus 1. The next consecutive integer. The first one was 3. The next was 4. The first one was 15. The next was 16. You add 1 to it. So it would be A times A plus 1 is equal to 72. That's how you do consecutive integers. What if it said consecutive even integers? You want A to be the first one? Okay, what would be the next one? Even integers. Pick an even number, any even number. 2, what's the next even integer? 4, how'd you get it? Add 2 to it, right? Okay, so it would be A times A plus 2 is equal to blah, blah. What if you had odd integers? What you want the first one to be? No, a letter, variable. Say again? C, okay, C. What would be the next odd integer? Say again? No. If C's the first one, pick some other odd integer. 1 would do. What's the next odd integer? Say again? 3. How did you get from 1 to 3? Add 2. So even or odd, the first one's C, the second one's C plus 2. If it's consecutive integers, C plus 1. Even or odd, C plus 2. Okay? So that's the same. Okay? They love those, so be ready for those. All right. Now, I see people closing up shop. Does that mean something? No, it can't be. We're just beginning to have fun. Oh, wait, we have another minute. What are you talking about? Okay, let me tell you what we're going to do next. We're going to skip chapter 4 for now. We're coming back to it. We're going to skip chapter 5 for now. We're coming back to it. We're going to move on to chapter 6. Okay? And in chapter 6, you see, chapter 6 begins where we left off in 3. Okay? I'll get there in a minute. Chapter 6. Goodness, that's a long chapter. Okay. All right. Chapter 6 are quadratic equations. Guess what most of these have been? Quadratic equations. What do it mean by quadratic? Yeah, you can pull them if you're factoring. So we're not going to do 6-1. Complex number, there's nothing in our course description that says anything about complex numbers. Actually, what I am going to do is do a quick slideshow of it. We're not going to do it. You're not responsible for it, but I want you to be exposed to it. So I'll do a quick slideshow of 6-1, but then we're going to start in 6-2. And 6-2 is quadratic equations, which is basically what we've been working on. Okay? So we will do that, and we'll solve quadratic equations. But I'll do a quick slideshow of 6-1. Okay? I think we're out of time now. And no extra charge for the extra minute either. Okay, good deal. Yes, ma'am.
Are you for sure that I can work from home for the rest of the day?
I'm not sure.
Okay.
If I'm not too sticky, I'm
Matt
not.
wanted me to ask.
Oh,
To
okay.
make sure about class.
Oh, no,
So
I'm
this
going to
time
have
we'll take-
class. I'm going to wait until, not after this class, after all my classes.
Okay.
Yeah,
So
it'll be
class is still on.
Yeah, for him, yes.
Okay.
Lucky dog him, you know.
Thank
Yes,
you.
ma'am. That's right. Sure. You mean on the quiz? I can look at it and tell you if your procedure's right. I'm not going to tell you if it's right answer or not. Okay. You have something? Technically due Wednesday, but as soon as you finish it, you can turn it in. If you need more time, you can do it. Okay? Number 4. Okay? It even tells you what to use.
Yeah.
What's that? Not one with staples in it. If you just sort of fold the corner over, I'll deal with it. Okay. Now that's a Z, not a 2. Is that what?
No, that's a Z. But
Huh?
I just wrote, it's just like a 2, but that's a Z though.
That's a Z. Okay,
Yeah.
good. Okay. So you got 3Z plus 1 plus 2W. See, now the only thing is you reversed. See, this one's the difference. So that's what you have to change the sign of. Good deal. Thanks. You see what I'm saying? You factored this right.
I broke that down because it's 2, 3Z, 3Z.
Right.
And then I broke that down to 2W plus 2W minus 2W.
Okay. But here's what I'm saying. If you multiply these two together, you get 2Z plus 1 times 2Z plus 1. That's 2Z plus 1 squared. Positive. Multiply these two together, you get minus 4W squared. You got your signs back.
So which signs I got backwards? That one?
Okay.
And that one?
Well, you see, you're leading off with this. This is going to be the plus one. And then this is the one that you do plus or minus. If you just flip these two, both of those, then you have it right. But you keep those together. The 3Z plus 1. This one goes there. This one goes there. This goes in front. That goes in front. You see what I'm saying?
Oh, you saying switch? No, I did it right here. That's not my answer.
Oh!
That's my answer right here.
Okay, now that
Those are
right.
my answer right there,
Okay.
and then right there. But then I changed all the signs right there and made that to that.
Okay, that's perfectly fine. Yeah.
Okay.
This, yeah.
Yeah.
Okay, yeah.
I
I just looked at the first step. Yeah.
Okay.
Good.
Okay. Now, I seen a question like this on the quiz. Let me read out the quiz. I did not understand fully.
Okay.
It was solving an equation, but it confused me because I know when you factor the equation for 0 when you add or whatever. But right here, the variable was on this side, like AB squared. It was like B minus AB squared equals 0. How would I go about to be the first step to go back to solve that question? That wasn't the question on the quiz, but there's one similar to that.
All right. Yeah. Okay. There's what was given, right?
Yes, sir.
Okay. You're going, and you already got a 0 here.
Yes, sir.
What you want to do is factor, right?
Yes, sir.
What you always look for first.
Greatest common factor.
Right. And do you see any common factor between those two terms?
I do 2.
No, 2's not in this one.
I do not.
Yes, you do.
Oh, B.
B. Okay. Factor out of B. And what does that leave you? Write down the B, and then you don't have to do it now.
AB, 8 squared minus B. Factor out of B. 8.
I said factor it out. When you factor, I'll do it. Okay. It's B minus 8B squared equals 0. That's just a square. That's ugly too. Factor out the B. That means factor out of both ones. That means you put a parentheses. What's left here when you factor a B out of B?
Minus negative.
B into B.
B to B
1 minus B into 8B squared.
8.
8B. There's your two factors. Right?
I was looking at some videos last night trying to figure it out with some of the past classes, but I couldn't. None of the questions we worked in class relate to this. I mean, they didn't.
They do. They're just distant cousins.
Okay.
And then you got two things multiplied together, gives you 0. That means either.
Did I tell him right?
I-
Right there? On that problem, how you can do it?
So that's what he told me to do.
Can you do it the other way?
You can, but
By that negative B, negative AB squared?
yeah,
To get it out of the negative form, can you write that negative 1 like I did?
you could, but it's also fine to just do it like this. I mean, both ways will give you the right answer.
Mm-hmm.
Yeah.
Okay.
Yeah.
All right. I just wanted to make sure I was telling
Yeah.
the right way.
Yeah, that's one way to do it.
Okay.
It certainly was.
Out of 2 numbers.
you're good.
Two numbers are going to equal zero.
No, the product of two numbers.
Product of two numbers are going to equal zero.
What does that tell you about those two numbers?
Either
Yeah, right.
is a B times
No, either B is
B is equal to zero,
or
1 minus 8B is equal to zero.
exactly. So write those two things down. And there's one of your solutions right there. Right there. B is equal to zero. How about the other one?
I need to. I know I need to get B by itself.
Okay.
So I need to. I'm gonna need to add. Let's see. Add 8B
To both sides. That sounds good.
And I can either add it up to the zero too, can I?
Yeah, you add it to both sides. You got to.
And then gotta cancel out. And I bring the 1 down. And 8B is gonna equal to 8. Let's see. Plus. Let's see. 1 is minus. Bring that down. So. I'm gonna have to divide. Let's see what's that. 1 minus 8B cancels that out.
You get it right? Now what you got to do?
Divide
By?
by 8.
You got it. What does that give you?
1 over 8. 1 over 8 is equal to B.
Yeah. B is equal to 1/8.
So
Perfect.
we know that thing will be it. So that.
No. Both of them are it.
What's the bit?
Yeah. Nothing here says you can't have fractions. We love our fractions, don't we? Yes. Okay. Good deal.
Okay.
Yeah. If there's no restriction, don't throw any away. Okay. Only if the physical nature of it says you can't have that. Like you can't have a negative length of a triangle. You just can't do it. So throw that one out. This one, nothing says anything's wrong with something being 0 or 1/8 or a fraction or whatever. Negative, that's fine.
Okay. Well, I seen a lot of the equations that we done in class and stuff, and I looked back on the videos last night, and I was looking at them, and Saturday night I was looking back on them, and I seen a lot of the equations, that we done in class, but they all made sense to me. But when I looked at this right here, like the variable was on this side of the number,
Right.
it didn't make any sense to me. It
Yeah.
confused me.
Well, just take one bite at a time. Make sure all your steps you do are right. And the first thing you do is look for common factors. You said it. I didn't. You said it. And identify that B as a common factor. Factor it out. It works out.
And another one I was having trouble with too was factoring by grouping. And I looked at, I went back and looked at the videos too about that, and I didn't see it, and I was having trouble with that.
Okay.
I don't understand.
We'll find one like it in the book. I know there's plenty of them in the book like that. And I'll be glad to work them. Okay.
What time do your next class start?
9:30.
9:30.
Yeah. It's about 5 minutes. Chapter 3. Okay. Maybe it's 3/4.
know when you and if you got a negative, now you got to include your negative. If you got a positive, doesn't matter. You can just factor it out. But say okay, I know when you look at each one of them, you relate to it. Like if you got x in both sides of x squared, then you can you put that outside of your parentheses because them two are equal to each other, related or whatever. But say the thing that confused me was once I was doing the quiz or whatever, once I done it, like the x squared, like once I factored them two out and put it out here, then I had like an x left with nothing. So that equal to 1, wouldn't it?
Yeah. Just like on that, when you factor out a b, it gave you 1 left. Yeah.
So it's equal to 1. That's what confused me. So if I got a variable by itself, then that's going to equal to 1 anyways.
If that's what you're factoring out, like this one right here, you would split the x squared plus 2x. This would be a minus 3 x minus 1. So this won't quite work, but yeah, the common factor here is a minus 3. Factor that out, and you get x plus 2.
That's 2.
Yeah. So yeah, if you factor the whole number out, that. Let's see.
We got 3 in common.
Okay. Well, you got more than 3.
We got 3 in the x.
Yeah. Okay.
Over here, so I'm gonna put that with C.
Okay. Now, I like to write this underneath so I can keep up with it. So it's fine. So factor out 3x. Okay. Leave parentheses there. Okay, and what's left?
We got B left over.
B left over.
So B will go outside of parentheses, correct?
Okay, yeah, well, open a new parentheses, right there, yeah. You didn't really need one, 3x is fine to have it. Okay.
Here we have a.
Well, you didn't do that one. You factored the 3x out of these two. I see what you got out of this one. That left the b, but when you factor 3x and 3x, what do you get?
1.
Plus 1. That's what you were talking about, right? Okay, close that parentheses. Now what you got in the next?
I got a y in common, so
Plus y plus.
and we got a B left over.
So you factor a y out of by, you get a b. Y out of plus y, you get a plus 1. Plus 1. Okay. And then, common factor of b plus 1. What do you have left? Yeah, factor out of b plus 1.
So that'll be 1.
Yeah, right down to b plus 1. Okay. Put it in parentheses. Okay. What's left out of this term? You factor out of b plus 1.
3x.
3x. Out of this term?
Y.
Plus y. So we got.
That looks pretty simple.
Yeah. What?
I don't know why. Like I was getting in class, and then when I go home and practice it, I get it. But when I start taking the quiz, like I recognize problems I didn't understand. Like, I don't know.
What you might try, if you when you go home you still get it, then start doing every day. Just do a few like those, just to keep them fresh in your mind.
Okay.
Yeah, that probably would be a good idea to do.
Like, if you don't practice them, you'll forget them.
Yeah, exactly. That's it. And unfortunately, it is taking too long between sections, but this is quite a bit to do. So.
Yes, sir. Well, it's something different for me too. Coming to college, actually taking college subjects. I went through high school in ninth grade, and I started working full time. I've been working full time since like ninth grade. I passed my GED test. That's what I done. I didn't go through high school.
Yeah.
A lot. So it's different, coming to trying to. The GED test, I mean, the GED was hard. It took a lot. It took a lot of studying, a lot of stuff to get past it. That was probably one of the hardest things I've done in my life. Was going from not having nothing to getting the GED.
I know. From ninth grade to GED, that's a lot to cover in one test. Right?
And especially, the GED test, when you're in high school, the teachers, they teach you and you get quizzes and stuff like that. When I had to take the GED test, I had one shot to do it.
Yeah.
I had 100 problems, 150 problems I had to know it all. And actually, I passed reading, math, and science. I passed all three of them in the first try.
Excellent.
The math, I took it. I waited a while on the math. I didn't take it because I wasn't ready for it yet. So I waited like probably 3 months later, and I took the math. And I missed it by 3 points. But if I would have just stopped and quit there, I would have passed it because they changed the score. I made a 147 on the math, and they changed the score to 145. Passing now. Back in it was 150. I missed it by 3 points back when I took it. So I passed it back in September 2015. So I waited about 3 more months and I went back and took it and made a 156 on the math. So
fantastic.
About 6 points. Math is my high subject and what I made on it. But
Right.
it was word problems. I'm good at word problems. These word problems, I don't understand these too well. I'm not getting them too well. But when it comes to word problems and working out and solving problems, I'm good at it. I took the ACT and I made 18 in the math. I mean, I'm good at solving the word problem.
Excellent.
But I had a great word problem. I really needed a tutor in this class, but yet I had a B in 98. But I need this class. I think I need a tutor, but I really ain't got one right now because they don't have one to tutor. They don't have anybody tutor me right now. She had a guy.
Did you go down and check with her?
I did. I'm in the student support services. So I checked with her. She had a guy that's supposed to be tutoring me. He finished up like the highest math he can go. He's like one of the highest math you can go. He's supposed to be helping me in his class, but he ain't. He didn't. He didn't want to do it. I don't guess he never got back in touch with me.
Oh, really?
So,
We'll go back to her then. Tell her you need a different one, but he didn't get in touch with you.
I told her, and she said she didn't have anybody. She said that she got one lady that comes in on Tuesday and Thursdays, and I work all day on Tuesday and Thursdays. So I told her,
Well, I'm trying to. You hear me every day. I'm trying to recruit people to tutor. So we'll try to get someone else down there.
I thought about trying to helping kids in 90 and 98 and stuff like that.
Right.
I finished 98 with a B.
Yeah.
In class. But in 100, I'm needing a tutor in 100 right now just to help me. I'm trying to keep A or B in here, and I need a tutor to help me.
Right. Yeah. Well, just keep checking with her, and I'll keep trying to get people to go down there. And I'll tell them they need somebody to do Math 100 on Monday and Wednesday.
I'll do my best to stay after class a little while like I'm doing today and ask you questions.
Right. That'll be perfectly fine.
I don't feel comfortable asking questions like right in the middle of class. I can't do it. When you ask if we have any questions and all that. I've been diagnosed. I'm autistic. I've been diagnosed with Asperger's D10, and I'm not very social, and I don't really like talking in front of people. That's my pet peeve. I don't like it at all. And it makes I get real nervous, so I have a hard time talking in front of everybody in the class.
Right.
So I feel more comfortable talking to one-on-one.
Right.
Myself.
Yeah. Okay.
A lot of time, though, but
Yeah. Well, sometime you're going to be a nurse, right?
I am.
There's a few times, that you'll probably have to talk with more than just one-on-one. Most nursing is one-on-one, but there may be some circumstances you might have to do a little bit more. So
I'm working on it.
Yeah, work on it. Yeah.
But
Keep going at it.
it's something.
Yeah.
Public speech is gonna be my pet peeve.
Yeah, I can imagine. I'm not sure I would have liked that either. Okay, good deal.
All right. We'll see.
Okay,
Have a good.
you too. Thanks.